All right, so we're going to do our quick review of complex numbers. Remember that I equals the square root of -1 and that I squared equals -1. So the first thing we need to be able to do is simplify I to any power. So we need to rewrite it with an even power. So we've got I to the 38th times I. Now we got to take that I to the 38th and rewrite it using I squared, because we know that's -1. So we have I squared to the 19th power times I. So now, since we have I squared to an odd power, we know that will create a -1. So you have -1 times I, which simplifies to -I. Make sure you know how to do this. You will definitely see this on the ACT, the SAT, some sort of standardized testing. All right, simplifying negative square roots. So -1 times 12. 12 is 4 times 3. We found that perfect square in 12. So 4, well, the square root of that's 2. And the square root of -1, well, that's I. So we have 2I radical 3. Now -25, we got 25 times -1. Well, the square root of 25 is 5. And the square root of -1, again, is I. So we have 5I. All right, square root of -7, -1 times 7. 7 does not have any perfect squares, so we just have I radical 7. Again, make sure you can do this. Be very important for us solving for complex solutions with quadratics. All right, so complex numbers. Let's remember that they have two parts, a real part and an imaginary part. So A is what we call the real part, and B is the imaginary part. It's got the I by it. Remember, we can't have them written in any other order. It needs to be A plus BI. If there's a denominator underneath of them, we have to break it apart, so we have the A plus BI. So absolute value, we've got, it's the square root of A squared plus B squared. You need to make sure you memorize this. Notice we do not put the I in with the B. It's just the coefficient. All right, so let's find the absolute value of a couple problems here. We've got -5 plus 3i. Well, our A value is -5, and our B value is 3. So we do the square root of -5 squared plus 3 squared. And remember, what we're doing right here is finding the distance from the origin. So we end up with 25 plus 9. We got to take the square root of that. So we have the square root of 34. Which is just under 6, because we know the square root of 36 is 6. So that's just under 6 units. Now 6i. Notice there's no real part here, so our A value is 0. You need to make sure you're distinguishing between the real part and the imaginary part. So what we have here is the square root of 0 squared plus 6 squared. So when we go to simplify this down, we've got the square root of 36, and that is 6. So if we think about which one's closer, number 1 is closer to the origin than number 2 because it's not quite to 6 units. All right, so adding and subtracting, super easy. We're just combining like terms basically. So if we look at this, we've got the real part in the first one's a 4, the real part in the second one's a 4, so we're going to do 4 plus 4. Now the imaginary part in the first one is -3i, and then the imaginary part in the second one is 5i. So we combine those. So we end up with 8 plus 2i. Notice we've got it written in the A plus BI form. This will be important when we graph. All right, number 2, since it's subtraction, we've got to distribute that negative sign through. So when we do that, we end up with 5 minus 3i. The first complex number stays the same. And then we've got plus 2 minus 4i. Now we can rearrange them so we've got the real parts together. 5 plus 2 and plus -3i minus 4i, which would give us 7 minus 7i. I know it doesn't get much easier than this, right? All right, so we're going to move on to multiplying now. Multiplying, we do have to be careful because we have to remember that I squared equals -1. So whenever we see an I squared, we've got to change it to a -1. So number one, we need to distribute that 3i to everything. So we got -15i. And here we've got 6i squared. Well, I squared is, that's right, -1. So we end up with -15i minus 6. And we got to make sure we rewrite it in a plus bi form. Okay, so the next one, we've got, 2 terms times 2 terms, like a binomial times a binomial. So we need to use the box method. We can use FOIL too, but remember the box method works for any size polynomial. So we got 4 plus 3i times -1 minus 2i. So 4 times -1, -4. -1 times 3i, -3i. 4 times -2i, -8i. 3i times -2i would give us -6i squared. That's right, we got to simplify the I squared. That's a -1. So that will turn into a +6. Now we can just combine our like terms, which are in the diagonals. So we end up with 6 minus 4 is 2. And then -3i minus 8i is -11i. All right, so let's talk about division. Remember, I equals the square root of -1. We're not allowed to have radicals in the denominator. So we're going to have to be thinking about the conjugates here to get rid of them. So the conjugate here would be -3i. So we need to multiply the top and bottom by -3i. Remember, for conjugate, we just change the sign of the imaginary part. So we distribute that through on the top. We end up with -27i minus 36i squared. And while on the bottom, we end up with -9i squared. So now we got to get rid of those I squareds because they equal -1. So we end up with 36 minus 27i. It's a sad looking I there. And then +9. Now we need to look and see if we can reduce this because we still have to break it apart. Notice we have that denominator there. So we can do, well, 36 over 9, I think that reduces to what? 4, yeah? And then we have 27i over 9 reduces to 3i. So we got 4 minus 3i. Make sure you break them apart. Okay, number 2, we've got to multiply by 1 plus 4i because we have to change the sign of the imaginary part. So again, we've got to do the box method for the top, or we can do FOIL, however you want to look at it. So we'll do FOIL on this one just to save a little space. So we got 2 plus 8i, the inner gives us 3i, and then outer and last, 12i squared. We combine this. Now remember, when we make conjugates, really we don't have to do the box method. It's first times last times last. So we can kind of avoid the box method there if we remember what a conjugate is. So we can simplify this. So we have to make that a -12, and we can make in the denominator that becomes a +16. So 2 minus 12 is -10, and then we've got 8i plus 3i is 11i, and well, 1 plus 16 is 17. And we need to break this apart. So we have to have -10 over 17 plus 11i over 17. And it looks like the bottom of my recording got cut off. Those are 17s in the denominator. All right, so graphing. Again, this is one of those things that if you don't know how to do on the ACT, might be impossible, but these are so easy to do. So remember, the real part is just like your X movement, the real axis. And then the B part is the imaginary. So we'd go back 4, up 3. Now for B, we go right 3, up 2. And then C is -2 minus 5i. So we go back 2, down 5. Doesn't get much easier than that. So just remember, the real part is the X movement, and then the imaginary part is basically the Y movement. And don't get confused just because they're not written as an ordered pair. And if we do the absolute value of them, we could find their distance from the origin. Just go home and do that for fun.